Hello, this is the first video about logical programming. In this video we will cover the basics, and the basics are defined by questions, rules and relations, facts, and I'm not sure about the English word, empty clauses. These four, let's call them words, are words defined by Mr. Horn, and there's a specific term like the Horn scheme or the Horn method. I'm not sure which is the right term. The direct translation would be something like the Horn clause. But names are not too important. We care about what is inside the names. Okay, what is this stuff? These are basically just names for rules, or better for specific forms of a formula, of a logical formula. This is what this basically is, and I will explain what all these mean in this video. But before we get started, just a little bit introductionary math. Imagine we have this statement: I is greater than 5. And I is smaller than 9, which is basically a statement. I hope you understand what is written here. And we can, for example, put in the front, sorry, this is an assignment, 6. And now we have a logical statement. And we can write the truth table about the statement. So something here, and then you have like true or false in various things. I hope you've seen all this stuff before. So this is just basically a mathematical way of writing how I is looking like. I hope you also understand that this could be rewritten as this one. And here we have just the same inside. So it's not this or this. And as we're working inside the logical field, we don't use this kind of arrow, but we use this kind of arrow. I hope you have seen all this stuff before. And to make this more general, we could write something like A, whatever it is. And on the right side, we have B and C. Of course, the direction of this arrow doesn't make any difference if we just invert the whole thing. So this is the same statement. Can be true, can be false. Let's give you a little bit longer example for that. We have this formula. As you already figured out, maybe I don't know how to say this arrow in English, but I hope you know, so I don't need to say it. So we have this formula, and of course we could have just a random different formula that looks like this. But now, now let's start with all the Horn stuff. Let's start with this stuff, just to explain to you that we're going to start now. We define a rule now. We say that this is not allowed. Why it's not allowed? Because it's an or. We don't want ors on the right side. We don't want ors on this side of the arrow. There should only be ends. So rule number 1 is only end on the right side. And we have more rules. We have a second rule. We have a rule that all these things that are connected by ends must be atoms, as well as this must be an atom. Let's call them items. Yes, there is a very special word for these things, basically atoms. But there's a more general word, but I don't know that, and it doesn't matter. What this means is, usually you could say, okay, C is actually equal to T and P, for example. But an atom is something that you cannot divide in something like this. So C itself must be either true or false. There cannot be a smaller part. This is what an atom is. Hope you know that already. This is rule number 2. Rule number 3, and this is maybe the most important rule actually. On the left side here, there is only one atom, or being more precise, at the maximum, one atom. What does it mean? We cannot have something like this, because it's 2 atoms on the left side. We only want 1 atom on the left side. And a very easy rule is the arrow always goes in this direction. It's always this direction. We don't have this kind of arrow anymore. This is a very important rule set for this Horn stuff here. Okay, based on this rule set, how can we actually simplify this rule above? We can write it a little bit more shorter if we just divide it and of course write correct letters. Damn, what's wrong? Okay, so we just write a comma because we know it's always connected with an end. So we don't have to write this long and big end. We just write a comma. Let's make a stroke here, and let's say this is like one possible formula that we can form out of these rules. Another formula that we can form, if we look at this one very closely, we can just say that whatever is here is empty. there must not be an atom here. This can be empty. And sometimes people use this square for showing that it's empty and there's nothing there. And it's also not forgotten. This is one thing that we can say, because we have max 1 atom. Oh, I hope you also understand that this and this is not the same. And to make this more clear, let's remove this one on the top. Another way that is possible to write here is an A on the left side, but nothing on the right side. So from nothing comes an A. And the fourth thing we can have is from nothing, we get nothing. Okay, so according to these rules on the right, we can create these rules on the left. And these are, let's call them horn rules. I'm going with the scheme, sorry, because it's a way of writing that stuff. Now we want to give each of these patterns a name. And the name of this one is a relation or rule. The name of this one is a question, or sometimes also referred as the goal, or maybe the goal clause. This one is called a fact, and this one is an empty clause. Why it's an empty clause? Because it's empty on the right and empty on the left. Although on this point I should emphasize that I translate these words freely from the Japanese, and they make sense to me in English, but there might be different words used in your textbook or from your teacher, because I'm not a native speaker and I don't learn this stuff in English. But it's more about the idea, and if you understand this, then you will understand everything else. Okay, this is the very important thing of this video. Now I want to explain to you why are we calling it that way. Let's start with, I think, the most easy one. Okay, hell, this is the most easy one. It's an empty clause because it's empty on the right and empty on the left. Let's forget about this. Let's start with this one. It says, if you have nothing on the right side, it will be A. So basically it says it's always A. But wait, I said this can be, or you learned in math that this could be a true statement or it could be a false statement. Okay, so, but I say it's always A. That doesn't make sense. If it's a false statement, then it's of course not A. Here's also one important thing. I'm not sure if this is a rule in logical programming in Prolog or in this field, but in general, you think that all these things within logical programming are true. You expect them to be true. So when you want to write, for example, you expect A to be false, then you write it like this. You also might find some things that are written like this. Might also be not A. But in general, you expect things to be true, especially these kinds of patterns. And you want to ask, are they true? But you never ask, are they false? You never expect them to be false. This is very important. So in your way of thinking, you must erase this part. And then it makes total sense. You say, okay, if you guess that this statement is true, if this is something that is given to you from the textbook, from the teacher, and it is given as true, then you understand that from nothing, A is always valid. You can, of course, just rewrite it and say, let's turn this around and say, either nothing is false or A is true. And as this is nothing, you can basically just erase that stuff and say A is true. This is what is left. This is why it's called a fact, a true clause, basically. If you have any questions about this, if you're confused now, just ask in the comments. Let's go on with the next one. Let's start with this one. It's a little bit more easier. I don't explain too much. This is a relation. And the reason why it's called like this, because you say you relate the stuff on the right side to the stuff on the left side. Okay, let's make a concrete example because A, B's, and C's are not really understandable. You can say one atom is it's 3 o'clock and one atom is I've got my shoes on, and therefore it's clear that I go out. So this explains the relation between the time and the fact that I have shoes on and the fact that I'm going out. I hope this makes things more clear. And then you have a question. This is a little bit different in interpretation. You have something on the right side, or even better, let's use this one. You write it like this. In this situation, you want to ask about the relation. You say, it's 3 o'clock and I have my shoes on. What is the outcome of that? What is the conclusion of that? And the reason why it's called a question is because I asked the question, what is the conclusion? What is the outcome? And the reason why it's called a goal clause is because this is the initial thing that you also in Prolog ask. So you always write a program, or you always think of logical programming or logical statements in general when you think about math. You have a set of rules here. And now you have a question. And you ask, is the question true or is the question false? So you created a new theorem, and you said, if this is given, this is given, this is given, this is given, then all prime numbers are calculatable. Prolog sometimes goes a little bit further in this case and says, you have these rules, what is the outcome? You can't even say that. You can also say what is the outcome if you make it with paper and pen. It's not that hard. Depends on where you end within the algorithm, but that's for later on. Okay, I don't want to spend more time talking about nothing. Important things of this video is basically the names for these patterns and the patterns itself. We have an empty clause, we have a fact, we have a question or a goal clause, and we have a relation or a rule. And this all is defined in the, I don't know how you say it in English, let's call it the horn scheme. Now you're ready for video 2 to understand the next step towards real programming in logic. Thanks for watching. And no, we're not finished. This is very important. I realized that after shooting all the other videos. So this comes at the end. I forgot to explain the translation between facts and stuff and usual stuff. So for example, if you want to say that I am stupid is a fact, then you would write it like this. So what you used to write just like this is now being written as this with the empty clause on the right side. And when you want to express something like not stupid, like I'm not stupid, then you would translate this to the actual question. This is the translation. This is what you used to write, and this is what you're going to write now. Sorry, I forgot the I. And this is what you used to write, and this is what you're going to write now. What I want to emphasize is, remember that this question clause, like B, C, D, E, F, let's put them all together and call them Z. There's a lot of stuff inside Z, maybe. Then remember that this is, I don't know how you actually write that. This is equal to not Z. Keep that in mind. That not Z is equal to this stuff. Why? Because you know the rule. I'm sorry, I turn around the arrow again. This is the same as this. Not A or B is equal to A, therefore B. We apply the same rule here, just that on the left side it's empty. And also don't forget this if you're looking at the relation rule, the relation clause or the rule clause. You can also write this with an or, and all these are negative. So with negative, I mean, let's write it down here. It's like B, C, D, B. Okay, thanks for watching.